In this lecture, we are going to discuss about the Millikan Oil Drop Experiment. In 1897, it was J.J. Thomson who discovered the negatively charged particle electrons by using cathode rays tube experiment. The negative charge electron was discovered by J.J. Thomson. However, it was not known till that what is basically the exact amount of negative charge on electron. In order to discover the amount of negative charge on electron, Robert Millikan and Harvey Fletcher performed in 1913 performed Millikan oil drop experiment, and on the basis of Millikan oil drop experiment, Millikan and Robert Fletcher discovered that the amount of charge on electron is around 1.6 into 10 raised to power minus 19 coulomb. So now, dear student, let us discuss the construction of the instrumental setup which Millikan and Harvey Fletcher used, and secondly, let us discuss that how from the Millikan apparatus or from the Millikan experiment, they concluded that the amount of the charge on electron is 1.6 into 10 raised to power minus 19 coulomb. Dear student, Millikan oil drop experiment consists of a chamber. This was a chamber which was evacuated. The reason of evacuation of a chamber used in Millikan oil drop experiment was there to avoid any kind of unwanted reaction inside the reaction chamber or inside the experimental instrumental chamber. Millikan oil drop experimental chamber consists of two types of electrode. One electrode was basically has a pores or hole inside it, whereas the second electrode was basically a solid metal. These electrodes were connected with a potential source or with a power battery. Suppose that this is a representation of a power battery. Power battery has a positive terminal and as well as negative terminal. So Millikan used DC power battery, and an electrode which is connected with a negative terminal of the battery is known as cathode. So the electrode which has a hole in it was basically connected with negative terminal of battery and it was cathode. Whereas the electrode which is connected with the positive terminal of battery, such types of electrodes are known as anode. So dear student, the role of cathode is to push the electron, and the electrons are basically present or on the surface of the cathode, whereas the role of anode is pull electron toward itself, toward the positive terminal of the battery. So anode has a positive charges on it. So now we can write it like this: cathode has a negative charges on it, whereas anode anode has positive charges on it. The Millikan oil drop experiment instrument was connected with apparatus or with an instrument known as atomizer. Atomizer. Suppose this is a schematic representation of atomizer. Atomizer is also known as sprayer. Sprayer. The role of a sprayer is to introduce a gas molecule introduce a small particulate of oil inside the chamber of an apparatus. So oil molecule was basically introduced through atomizer inside the Millikan Oil Drop Experimental Instrument Chamber. The instrument was also connected with other components, like one of the component is known as X-ray source. Suppose that this is a representation of X-ray source. It has also a connection of arc lamp. Millikan Oil Drop Instrument arc lamp is also connected with microscope. So the role of microscope is to analyze. So this is the representation of microscope. 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 So now, dear student, all the components which are connected with a chamber of Millikan oil drop experimental setup, all these have important roles, such as the atomizer basically introduce oil molecules in a small molecular fashion inside the chamber of the instrument, whereas the X-ray source basically introduce or incorporate highly energetic X-ray radiation inside the reaction chamber, and these X-ray radiation will interact with the molecule of oil. They basically ionize oil molecules, and the interaction of X-rays with oil molecules are basically monitored by introducing arc lamp inside the chamber. Basically, arc lamp causes the spark or light of the molecules which were interacted, or oil molecules which were interacted with the X-ray source, and the movement of the molecules or ion of the oil are monitored by a microscope. So what Millikan did in his experiment, this student, Millikan incorporated the oil molecule inside the reaction chamber. Since you know that these oil molecules have a mass, these oil molecules have, sorry, let me write in white, make it clean, or make it very clear when we will write in a white. So suppose that oil has molecules, these molecules have a mass and weight. This means that these oil molecules have a gravitational force on them, F into G. Gravitational force will cause the oil molecule to move toward a downward direction in the, and they will pass through the hole, and they will basically cross the hole, and they will basically arrive inside the reactor, between the electrode of the reactors of the chamber, sorry. So now, when the gas molecule, due to gravitational force, they basically come in between the positive and negative electrode of the reaction of the reactor, there is also a connection of X-ray source. And when the X-ray source produces highly energetic X-rays, these X-rays will basically interact with the molecules of the oil, and when these X-rays interact with the molecule of oil, the oil will get ionized into positive charge ion, and as well as positive charge, and as well as negatively charged electrons. And dear student, since you know that same type of charges, suppose the positive, same type of charges repel each other, whereas different types of charges or opposite charges, basically opposite charges attract each other. Since you know that the electrodes are basically connected with positive and negative terminal of the battery, so the cathode is connected with negative terminal of battery, it has a negative charge on it, and whereas anode is connected with a positive terminal of the battery, so anode has a positive charge on it. So now, dear student, the charge on positive ion is basically plus, is positive, so they will be repelled by the positively charged plate or by the anode. Whereas the electron has a negative charge, they will be attracted by the positive charged plate or by the anode. So now, interesting question here arises that Millikan used a specific trick. He basically balance the electric force with a gravitational force, and when an electric force of a molecule is balanced with the gravitational force, electric force of ion is basically on ion is balanced with a gravitational force, so these ion will be in stationary position between the cathode and anode inside the reactor or inside the chamber. So when the ions are balanced, positive ion are in stationary positions, so this means that the mass of the ions or ion molecule was ion positive ion was known. So on the basis of that, we can basically calculate the amount of charge on these positive ions. So now let us do some mathematical calculation. The gravitational force, what Millikan did, he basically balanced out the gravitational force with electrical force, F into E. So as you know that gravitational force is mass into gravitational energy, it is equal to m into g, whereas electric force is charge into electric field. And as we know that electric field E is equal to V by D. D is, dear student, is basically it is a distance between the two electrodes, cathode and anode. So it is D. So now in suppose this is equation number 1 and this is equation number 2. Incorporate equation 2 in equation 1. We will get that mg is equal to q into v by d, and q will be equal to, so then Q will be equal to mgd divided by V. So now, dear student, it is obvious from this equation that m is basically a mass of a m is basically it is a mass of an of ion, and g is basically a gravitational acceleration. Both these are known. D is basically a spacing between the two electrode, and V is the applied voltage. So all these physical quantities are known. On the basis of this, that charge on a positive ion was calculated, and Millikan noticed that when he calculated a charge on the positive ions, Millikan noticed that the value of the charge on these positive ion was like has a specific pattern. It was like, suppose it was in zeptocoulomb, okay, the value of charge was in zeptocoulomb, which is very small quantity, and it was basically varying in a ratio of or integral multiple of 160. Suppose one positive charge has a value of 160, the other will have a value of 320, and next one have a value of 480, and the next one has a value of 640. This means that if if any ion is losing one electron, so its charge value was around plus 160. And whereas if the ion is losing two electron, its value will be basically changes in a multiple of 160, so it was 320. Similarly, if an aryl molecule aryl ion, positive ion, lose 3 electron, its value basically changes with the multiple of 480. So basically the value was basically of the charge on this positive ion was basically increasing or decreasing with multiple of 160. This means that the 160 is basically a value of an electron. Zepter cooling was a value of amount of electron, which was varying because ion was basically losing electron. So which means that the amount of a charge on ion is 1.6 into 10 raised to power minus 19. Minus 19 is a zepto and zepto coulomb. So this was the amount of charge on the negatively charged electron. So, dear student, by balancing a gravitational force with an electrical force, Millikan and Harvey basically calculated the value of amount of charge on electrons. So now, dear student, let us conclude the Millikan oil drop experiment. In Millikan oil drop experiment, Millikan used a simple vacuum chamber in which he incorporated the molecules of oil, and these oil molecule has a mass and as well as weight, and due to this they will feel a gravitational force. And when these molecule passes through the positive and negative cathode, these molecules just basically move inside the chamber. And Millikan did a special trick in which he balanced out a gravitational force with a electrical force, and due to balancing out the gravitational force with electrical force, positive charge ions become stable. And by calculating a mathematics between a gravitational force and an electrical force, Millikan concluded that charge on positive molecule amount of charge on the positive ion is basically increasing or decreasing with integral multiple of 160. On the basis of that, Millikan concluded that the amount of charge on electron is 1.6 into 10 raised to power minus 19 coulomb. So this is all about the Millikan oil drop experiment for the calculation of amount of charge on electrons. Dear student, thank you for watching this lecture.